Hey everyone, ever wondered how a game saves your high score or how an app remembers your settings after you shut it down? Well, the secret is files. And if you want to give your programs that kind of memory, you are in exactly the right place. We're going to break it all down, super simple, step by step.
So here's what we're going to cover. First, we'll talk about what a file even is. Then, we'll get into the nitty-gritty of reading and writing. After that, we'll learn how to make our code totally crash-proof. Then we'll play with some real-world data, and finally, put it all together to build a couple of really useful tools. Let's do it. Okay, so first things first. Ever stop to think about what happens to all the information your program is holding when you close it? It just vanishes, right? Well, that's where files come in. They're what give our programs a long-term memory. Honestly, the best way to picture a file is just like a notebook. Your program can flip it open, jot down some important info, read what it wrote down yesterday, and then close it up, knowing that everything is safe and sound for the next time it runs. And if you want the more official definition, here it is. A file is really just a bunch of data that's saved together under one name on your computer's hard drive. The key word here, the one to remember, is permanent. This stuff sticks around, long after your script is done. Now you're basically going to run into two main kinds of files. You've got your text files, like .txt files, or even your Python scripts themselves. You can pop those open in any text editor and read them. Then you have binary files. These are for things like images, music, or applications. If you try to open one of those in a text editor, you're just going to see a wall of complete gibberish. All right, theory's over. Time to get our hands dirty. In this section, we're going to cover the two most basic things you can possibly do with a file. Get information out of it and put new information into it.
And it all starts with this one single function built right into Python, open. This is your master key for everything file-related. You just need to tell it two things, the name of the file and what you plan on doing with it.
Now look, this is the modern and by far the safest way to open a file. It's called the with statement. You say with open somefile.txt rs as f, and then you do all your work inside that indented block. The best part? When you're done, Python automatically closes the file for you. No forgetting, no weird errors, it's just the right way to do it. Remember how I said you have to tell Python what you want to do? Well, that's the mode. The big three you'll use all the time are R for read, W for write, and A for append, which just means add to the end. It's that simple. And you've got to understand the difference between write and append. Using W is like taking an eraser to a whiteboard. Everything that was there before, it's gone. You get a completely fresh start. But using A is like grabbing a marker and just adding a new note at the bottom. The old stuff stays right where it was. Mixing these two up is a classic mistake, so really let this one sink in. Okay, so you know how to read and write, which is awesome. But, in the real world, things don't always go according to plan. What if the file you want to read just isn't there? Or what if you don't have permission to write to a folder? Let's figure out how to handle that without our whole program crashing and burning. These are pretty much the four horsemen of file errors. You will, I promise you, see file found error a million times. It usually just means a typo in the file name. Permission error is another really common one, especially when you're working on servers or other people's machines. And that's really the secret to writing solid professional code. You don't just hope for the best. You anticipate what could go wrong and you build a plan for it. And this is our plan B. It's a try-except block, and it's like a safety net for your code. You put the risky stuff, like opening a file, inside the try part. Then you tell Python what to do if a specific error happens. So you can say, except file not found error. And if that happens, your program runs your plan B code instead of just giving up and crashing. It's incredibly powerful. Okay, theory is cool, but let's get down to business. In the real world, data isn't always in a simple little text file. It's often structured. So let's see how we can handle one of the most common data formats out there. If you've ever opened a spreadsheet from Excel or Google Sheets, chances are you've dealt with a CSV file. It's a super common, text-based way to store data in rows and columns, and lucky for us, Python has a fantastic module for dealing with them. And this is a total game changer. Instead of getting a raw string of text you have to split up yourself, Python's CSV module can turn each row into a dictionary. That means instead of having to remember that the name is in the first position, you can just ask for it by name, like row name. It's so much cleaner and way less likely to break. Sometimes your program just needs a little scratch pad, a place to store some calculations or data halfway through a process, but you don't want to save it permanently. That's what the temp file module is for. It lets you create temporary files that Python automatically deletes when you're done.
It's clean, it's safe, and it keeps your folders from getting cluttered.
All right, this is the moment we've been working towards. We've got all the pieces. We know how to read, write, and handle errors. Now, let's put it all together and build a couple of mini projects that actually solve real problems.
First up, we're going to build a neat little tool that can read any text file you give it and tell you which words are used the most often. This is a classic first step in any kind of text analysis.
And check that out. So how do we get this? Well, it's actually pretty simple. We open the file, read everything into one big string, and then split that string into a list of individual words. Then, we hand that list over to this amazing tool called Counter from Python's collections library, and it does all the heavy lifting for us. Just a few lines of code, and you get this kind of powerful insight.
Okay, for our second project, let's build something for all the tech support and systems people out there. We're going to write a script that can scan a huge, messy log file and pull out only the important lines, the ones that contain the word error.
And boom, there's the result. Our script just opens a log file and reads it line by line. For every single line, it does a quick check. Does this line contain the word error? If it does, we write it to a new, clean report file. Imagine trying to find these 2 lines in a file with 10,000 other messages. This little tool just saved you a ton of time.
So there you have it. We've gone all the way from what is a file to building actual useful tools that can analyze data. You now have the fundamental skills to make your Python program save data, read data, and interact with the real world. You can officially give your code a memory. The only question left is, what are you going to build first?